So this video is solving one variable inequalities, which is going to be very similar to equations and also a review from your 8th grade year. I can solve one variable inequalities, and you're also going to be able to graph one variable inequalities by the time you are done with this video. So inequalities, what are there? So you might recall from 8th grade year, inequalities are the less than, greater than, less than or equal to, greater than or equal to. There's also two others that a lot of people are associated with inequalities, and that is your equal sign, and then the opposite of equals is does not equal to. So what are they used for? We use inequalities for comparing. We use inequalities also to represent a large set of numbers, which is mostly what we're going to do today if you want to be all the numbers lower than a certain given number, like 10. Alright, so our inequality signs, these are words associated with these inequality signs. We have the less than symbol, which means less than or fewer than, and there's also probably a few others you can come up with. This is less than or equal to. Again, notice the only difference is the bar. The bar means then we are equal to. It can also mean at most or no more than. We have the greater than sign, more than, greater than, or higher than. Again, there's probably a few others you can think of. And then when you have the bar underneath it, well, now it's greater than or equal to or at least. The two that tend to give the students the most trouble is at most or at least. But if I tell you you can have at most 5 cookies, that means you can have 5 or less. If you can have at least 5 cookies, that means you can have 5 or higher. You kind of have to put in context to kind of help you out. So we see inequalities a lot. Right here is a speed limit sign. Now I know generally people will go beyond 50, but by law you're not supposed to go beyond 50. So I can write inequality. I can say your speed and 50 should be less than or equal to. The second sign is a sign you would probably see at an amusement park, saying you must be this tall to ride alone. So you could say tall, or you can do H for height. The number here is 52, and you need to be greater than or equal to if you want to ride this ride alone. So here are some phrases or sentences that we can write inequalities for. The food will cost less than $7. So in each inequality we need a variable. So I'm going to do F for my variable. The number would be 7 from here. And I am less than, so 7 is the highest, so we're going to eat 7 as you might have been told when you were younger. We are going to less than. B, you need to get at least an 82% on the test. So I'm going to go T for test. 82 is my number. And then I need to get at least an 82, which means I actually need to go higher than 82. Do not be fooled by the word least. It does not mean lower. It means you're actually going higher. You can have at most 2 cookies. So I'm going to do C for cookies. 2. And at most means 2 is the highest, so we're going to eat 2, but I can have 2 in this case, so I'm going to do less than and equal to. So this is a situation which we're trying to figure out how many bracelets Katie can buy. So it says Katie has $20 and wants to buy bracelets that cost $1.30. But first she has to give her little brother $3. So Katie has $20. We have to take away 3 because she lost 3 of her dollars to her little brother. But now each bracelet costs $1.30. So I can take 17 and divide it by $1.30 to figure out how many total bracelets she could actually buy if she bought the most, which in this case comes out to be 13.08 when it's rounded. Well, if we think about it logically, you can't buy 0.8 of a bracelet, so really she can only buy at most 13 bracelets. So my inequality I can write is B, and my number is 13, and she can buy less than or equal to 13 bracelets. So one of your objectives is that you need to learn to graph inequalities. There's kind of 2 things you need to remember, less than and greater than symbols. When it's not equal to, when we're graphing on our number line, we'll have an open circle. You can't equal to it. When we have the line underneath it, which means equal to, we need a closed circle. on our number line. And then we're going to have an arrow either going right or left on each one. Right here in the orange, this is a very important concept to remember. Always look at the variable. Just because the arrow is pointing this way does not always mean on your graph the arrow goes that way. Here, y is less than, but if I have it this way, y is also less than, and my arrow would still go to the left. So keep that in mind as we're solving and graphing our inequalities. One other important concept before we kind of get to the meats and the potatoes of this lesson, which is solving the inequalities, is we need to kind of fill out this chart to figure out if the sign always stays the same. So in this example, we have 2 and 4, and if I would compare 2 and 4, I would say 2 is less than 4. But if I add 2 to my original inequality, I get 4 and 6, which means 4 is still less than 6. So did my sign change? I can say no. Well, now we're going to subtract 2 from my original. So 2 minus 2 is 0. 4 minus 2 is 2. And then 0 is still less than. They're still face the same direction. So no, it did not change. Now we're going to multiply by 2. 2 times 2 is 4. 4 times 2 is 8. It is still less than. Now we're going to multiply the original by negative 2, so I get negative 4 and negative 8. Well, now, negative 4 is actually higher than negative 8. Well, in this case, now my sign is facing the other direction. So did my sign change? Yes. So the next one, we're going to divide by a positive 2, so I get 1 and 2. Well, 2 is still greater than 1, so no, my sign didn't change from the original. And then if I divide by negative 2, I get negative 1, and then negative 2. Well, negative 1 is actually greater than negative 2, so yes. So notice when I times by a negative or divided by a negative, I had to change my sign. This would be important when we're solving, because anytime when we're solving you multiply by a negative or divide by a negative, we have to change, or you might have heard you have to flip your sign. Alright, so let's start solving. So we need to solve, but we also need to graph each inequality. So just like yesterday, I'm going to draw my line to keep my two sides the same. I'm going to minus 4. So notice the procedure is very similar to yesterday. I get 3x, so equal sign, we have a less than sign. 3, we divide by 3, so we get x is less than 1. So one of the differences is that you actually have to graph your solution. So on your number line, I just need the number from the solution. You need an open or closed circle since it is just less than and not equal to is open. And x, again, look at the variable, x is less than 1. So my line will go lower than 1 to the left. So on B, I have 7 minus x equals 5 halves. So I'm going to minus 7. To both sides. So I get negative 7 is less than or equal to. Now 5 has minus 7, if you want to make this into a decimal, is 2.5 minus 7, which gives me negative 4.5 or 4.5, however you want to look at it. If I divide by a negative 1, because x is negative. Now here, since I divided by a negative, I need to flip my sign. So x is greater than or equal to 4.5. Very important, and part that students tend to forget about flipping your sign. So graphing it, do 4.5, close circle because we're now equal to, and we are going to go greater than. C, we see a parentheses, so we're going to distribute. We get 60 minus 24x is greater than 6. Move your 60 over. Get negative 2x is greater than, hopefully you caught my mistake. This should be negative 24. I forgot to distribute it completely. Negative 54. See, even teachers make mistakes. divided by negative 24. Alright, so I divided by a negative, so hopefully in your brain you're saying, oh, I gotta flip my sign. X is less than, and then negative 54 divided by negative 24 gives me 2.25, or 2 1/4. So then we're going to graph. We get 2.25, open circle, and X is less than, so we'll go to the left. So in D, we have a lot of our equation strategies we're going to have to use. First, we're going to distribute the negative 6. So I have 5x minus 6x minus 42 is less than or equal to 3x plus 9. So I have 5x minus 6x. We have combined like terms because they're on the same side of the line. So that is negative x or negative 1x. If you have the 1 there, that isn't wrong. Less than or equal to 3x plus 9. I need to get my x's on the same side, so I generally move the smaller one, which is the negative x. So I'm going to add x. This makes 0. So I get negative 42. It's less than or equal to 4x plus 9. So I need a minus 9. This is negative 51. It's less than or equal to 4x. Divide by 4. So x is greater or equal to, I do not flip my sign in this case because I did not divide by a negative. And this comes out to be 12.75, I believe. Let's double check that with my calculator. 51 divided by 4. 12.75. Alright, so then last step we need a graph. Get 12.75. Close circle because we're equal to, and notice x is greater, so we are going to go to the right. One last example, putting with your lovely fractions. So remember common denominators and a reciprocal. So I'm going to move the 1/5. I'm going to add 1/5. Actually, we're going to back up. Notice, I jumped the gun. We have x's. We actually need to move the 3/2 x because I have x and x, so I need to minus the 3/2 x. Alright. So then this makes 0. So I get negative 1/5. It's less than. Now here we need a common denominator, which is 6. So I'm going to type this one and times it by 2. This one and times it by 3 to make a common denominator of 6. So I get 16 over 6x minus 9 over 6x. So I get 7 over 6x. So here I need to cancel this out to get them multiplied by the reciprocal, which is 6/7. Multiply this side by the reciprocal, because again with equations, what you do to one side, you have to do the other. I multiply by a positive, so my sign stays the same. I get negative 6 over 35. Graph, negative 6 over 35. Open circle, and this is what I was talking about, that you really have to look at the variable because my arrow is pointing this way, but x is greater than, so my arrow goes higher than negative 6 over 35. Right, so just review, remember it's the same operation as equations, however, you need to flip the sign when you multiply or divide by a negative number, and always look at the variable when you're graphing to make sure you're going the right direction. Do not go which way the inequality sign is pointing. And again, don't forget to do your reflection so I know that you watched this video.